Hey, Jody here with WeldingTipsAndTricks.com. I'm about to tackle this gravy job here. I've got about 50 of these tubes, and I got to put end caps on each end. And one of them's a little bit different. One of them's got a little flange on it. The other one's flush, already machined, beveled, not even a press fit. Slip them in, tack them, put them in the turntable here, weld them up. Gravy. I've mentioned quite a few times about doing work for machine shops, and that's what this is. And every now and then you get some sure enough gravy work like this. Like, all I've got to do is tack it up and weld it and then get a check. I got to get busy. Let's get into it. This is my welding positioner. It's pretty nice. Got a 3-jaw chuck on it. It only runs about 1 RPM though, because of some changes. I had to replace the controller box, and there's a lot to it. Anyway, I have used other ones like this particular MBC. I really prefer this type of a chuck because just speed of changing parts out, but I don't have that anymore. And this is the first weld I'm going to make here for this video. And you can see it's got one heck of a bevel on it, a lot more than it needs for the application of the part, but that's just what it is. Now, to set travel speed, to set speed on a positioner, here's a little trick that I use. I get a piece of tape, I mark off 1/8 inch increments and count 1001, 1002, 1003. And if I'm getting about 1 increment per second, I know I'm going to be in the ballpark for TIG welding. Now, because I've got such a big chamfer, I'm going to start off with a 1/8 inch rod. That's 3.2 millimeter rod, and I'm going to take a stab at 140 amps and weld one and see how that works out. So I've got one tacked up here. Let's weld it. That's not too bad. 140 amps is just about right. The puddle is, all I want the puddle to do is just nip those edges, but it's got to be hot enough that I can feed a little bit of rod in there to fill up that whole bevel. So we'll see what that looks like. It's not too bad. We'll see if we can tweak it and try some different stuff. Here I'm just using lay wire, doing a slight weave. Still 140 amps. It seems like it's going okay, but it doesn't look quite as good as the first run. So I'm going to turn it down 5 amps and see if that helps a little bit, and then maybe change the angle of the torch just a little bit. See if I can get a decent little weave pattern going. I need it hot enough to flow metal down into the bottom of that bevel, and then also not so hot that it just kind of smokes it, but not crazy about the way that one looks either. Let's take a quick break here and talk about pulse settings. And before we get into pulse settings, let me say this about pulse TIG. Most of the benefits, and there are some benefits, most of them are realized in an automated application, completely automated, where a torch is stationary, automated wire feeder, turntable so that you can lock travel speed in. Everything is locked in place, and then you start tweaking with pulse parameters, and you notice a big difference in bead profile or how much it laps over. And these are applications like aircraft parts, knife edge seal buildup, where we're dealing with heat input requirements and all kinds of things like that. I have a feeling most people I'm talking to today don't need pulse. It's not going to make that much difference for you. It's just something that's kind of cool to mess around with, and it's nice to understand. It makes perfect sense for me today on this job because I've got a semi-automated setup where I can just rest my hand and use a lay wire technique and just let the pulse put the ripples in the weld, and it just makes things go easy and makes it look nice. There's basically 3 settings when you're talking about pulse settings, and that's pulse frequency, that's pulses per second, also called PPS. There is pulse width, also called percent on time. That's the amount of time that the high current stays in place. So if I have a machine set at 100 amps and I have my pulse on time set at 50%, 50% of the time it's going to stay at 100 amps if I'm full pedal or if I'm using a torch switch. Okay, then background current is a percentage of that amperage. Usually, it's usually set up this way. Some machines are somewhat different, but usually background current is a percentage of that 100 amp high current setting. And say I've got it set, let's say I've got the background current set at 30. That's going to mean that it's going to drop from 100 to 30 amps for half the time. Now for these welds today, I'm using a torch switch, no foot pedal, so I've got to set things pretty close. So I'm starting off here on DC, 2T position because I'm using the switch, standard pulse, and I've got it programmed in and saved in the memory as program 2, high frequency TIG. My welding amp's around 200 to start with, 50% on time on the pulse, 40% background current, and 1.5 pulses per second. Not quite 3 seconds on the down slope, that's tapering off amperage, and then end amps 10. Post flow 8.5. All I'm really concerned about is keeping my tungsten silver. 0.2 on the pre-flow, 15 on the start amps, and only 1 second on the upslope. I want to get a puddle going pretty quick. And if I want to save this into the memory, I can just hold that button and save it. And once I get this dialed in, I will do that. And actually, the place that it got dialed in was at around 190 amps with those same settings. That worked out pretty well. And in just a minute here, I'll give you a nice close-up of the arc, and even we'll slow it down and talk about what's going on there for just a minute. 1.5 pulses a second, but now let me slow it down tremendously. So I'm going all the way up to 190 amps, and then it's backing down to 40% of that. And on something round like this, where I'm welding continuously, start to finish, it really helps kind of keep the heat from building up too much, and kind of lets it wet out just to those edges of the bevel and not wander much farther than that. And it just makes it easy for me. For something so monotonous, part after part after part, I can just lay the wire in there and pretty much daydream, and things will still come out okay. Once again, I settled in at 190 amps, 50% on time, 40% background current, 1.5 pulses per second. And that worked out pretty well. If I were to weld these by hand without a turntable, I'd probably set up some type of little scenario like this where I could put them on some V-blocks and spin them really easily and weld about half or a quarter, I should say, at a time. Spin it, weld, and you know, that's a possibility also. But if you got a turntable, you want to use a turntable. All right, let's try some different stuff here. In arriving at the 1.5 pulses a second and lay wire, I tried a few different things. I tried 1 pulse per second and actually feeding the wire. They say that when you're learning to TIG weld, that this is a good way to establish rhythm, using pulse just for that purpose, just to establish your rhythm of feeding the wire. And if you're going to do that, you can even drop down to less than 1 pulse per second, like 0.7, which is a pretty good setting for learning how to feed wire on that high part of the pulse. Now, I am able to try all kinds of different things today because I'm not locked into a certain weld procedure. The drawing, like I mentioned earlier, said weld per standard shop practice. That was the only details as far as welding. If there was a procedure for this, then I wouldn't have been able to go all willy-nilly with all these different things to try to learn something today. Well, we've got another end to do here, and that will be part 2 of this video, because we're going to use some different settings, higher amperage for the pulse, as well as do some welding with no pulse but walking the cup, and then also talk about different size cups and what they do and where you might want to use them. But that will be in part 2 of this video. That's a nice. Alright, now it's time for a little commercial pitch. I tell you that so you can bail if you got a problem with that kind of thing. One thing I have learned being in business, if I want to get something, I need to give something first. So hopefully I'm giving you good content every week. And so what I do at the end of every year is I take all the videos, I put them on a 4-disc set, because it takes 4 discs to get them all on. There's like 7 or 8 hours worth of stuff on there. So here's worth of work. And you can find these at weldmonger.com if you're interested. Thanks for watching.